The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome and thank you for attending this morning's webinar, A Public's Risk Level from a Pipeline Operation, a case study from Delaware, Pennsylvania. My name is Marissa Davis. I'll be facilitating for you this morning. So I addressed this in last week's webinar as well, but I'm sure there are a few new folks who weren't on the line. I just wanted to quickly reiterate why we decided to do these series of webinars. We were scheduled to present and had presentations ready to go for several conferences that were canceled. So we thought this would be a good way to share some interesting and relevant topics with you. We hope that you and your families are safe and healthy. And with that, let's get started, shall we? The host of today's webinar, G2 Integrated Solutions, provides responsive support and a comprehensive suite of asset integrity, engineering, GIS, field services, regulatory, and technology solutions that address asset performance through its lifecycle. For more details on our services, please visit our website at www.g2-is.com. And now I'd like to introduce you to our presenter, John Kill. John is the General Manager for our Gulf Coast Region operations here at G2. He's responsible for the leadership of our technical team and financial success of his division. John's got 34 years of experience in the oil, gas, and chemical industries with a background in business unit management, sales and marketing, technical services, including process safety consulting. We'll have a little time at the end of the hour to answer questions. So if you have any questions throughout the presentation, if you'll just enter them through the question function here on GoToWebinar, John will be happy to answer them. So John, at this point, I'll hand it over to you.
Thank you, Marissa. And thank you to everyone who's been able to join us today, take time out from your busy schedules. Yes, I know maybe not as busy as when you're in the office in some ways, but maybe busier with the remote working situations, trying to help out on homeschooling for your kids, and just making sure that your families are safe and healthy. And we wish all of you the best as we get through this situation. As said at the introduction, today we're going to discuss public's risk level from a pipeline operation, a case study from Delaware County, Pennsylvania. Before we get started, I wanted to provide a brief outline of what we will cover today. First, I'll provide some background on what got us started. How did we get to this case study, and what are the objectives of today's discussion? We'll go over the 2018 quantitative risk assessment work and report that was completed, and the public presentation that followed the completion of that work in the report. Today's discussion will then move towards a much more qualitative aspect, where we will discuss the observations that have been made based upon this experience and the lessons that can be learned for both the pipeline industry as well as anyone else that's involved in safety and risk management that's associated with major hazard assets. And for those of you who are not familiar with the term, major hazards, major accidents, are those that have a potential for infrequent yet high consequence accident events. And finally, as Marissa said at the end, we should have time available to answer any questions that you may have. For some background, in response to public apprehensions concerning the risks associated with two proposed pipelines that would pass through Delaware County, Pennsylvania, or referred to as Delco at different times during this presentation, county officials, through their Department of Emergency Services, commissioned G2 Integrated Solutions to complete a quantitative risk assessment. The objective of the risk assessment was to estimate the level of individual risk to those people located within the county of Delaware from the Mariner East 2 pipeline, which transports natural gas liquids, or the converted Adelphia pipeline, which transports natural gas. These risk levels that would be calculated would then be compared to other common sources of risk experienced by the general population. The report was provided to the public on the internet and then through a public presentation. It was hoped that by comparing the pipeline risk to other common risk sources and presenting these results publicly, that various stakeholders would achieve a better understanding of the pipeline risk. Let's cover the objectives for today. Our objectives for today's presentation will be to discuss the findings with regard to the individual fatality risk and the comparisons that were done to other common risk sources, as shown in the quantitative risk assessment report that was completed and submitted to the Delaware County Council and then presented to the public. It's not the intent to repeat all the details from that risk assessment report today, but to provide enough information so that you can get an understanding of the basis and the results that were achieved. What I believe that is going to be more interesting and more useful to those of you today with us is to hopefully discuss some of the public's concerns that the risk assessment was not really intended to address or scoped, and that there's lessons that can be learned from this unique experience. These are observations that were made by both the G2 Integrated Solutions consultants that completed the work and the Delaware County Department of Emergency Services, our primary point of contact, and who also continues to work with the asset owners and the constituents they serve on the balancing of the needs of both of these parties. Let's dive in a little bit into the risk assessment report that was completed. The 2018 effort that was used to determine the individual risk used methods and techniques that are used worldwide when conducting quantitative risk assessments. For the most part, this work was not unique. These assessments are done globally by professional risk practitioners all the time on pipelines and on other major hazard assets. However, what is unique was the opportunity to share and discuss these results in a public forum. The risk itself considered both full bore rupture and 50 millimeter equivalent release size events from the pipeline body. Release frequencies were derived using U.S. Department of Transportation pipeline statistics from the Pipeline and Hazardous Materials Safety Administration. The harmful consequences causing fatalities that were considered in the study included thermal radiation from jet fires and flash fires for the natural gas liquid pipeline and vapor cloud explosion overpressure for the natural gas pipeline. Now, process or design information that is used in these typical quantitative risk assessments usually comes directly from the facility owner or the design team. However, given that the 2018 pipeline risk assessment was for a public entity and was to be independent of other entities, the descriptions and operating conditions of both the Mariner East 2 and the Adelphia pipeline systems were taken only from publicly available information sources. Where specific information that was needed for the assessment was not detailed in the publicly available sources, conservative interpretation of the available information and experienced judgment was used by the risk professionals who completed the work to provide the necessary basis for the risk assessment itself. Let's talk about some details on the pipelines themselves. The Mariner East 2 pipeline is an expansion of the existing Mariner East pipeline system, and it transports natural gas liquids from Eastern Ohio and Western Pennsylvania to the Marcus Hook facility, which is just west of Philadelphia on the Delaware River. The material is then stored there for eventual domestic distribution and export. Mariner East 2 is a 20-inch diameter pipeline with a total length of about 306 miles, with approximately 11.5 miles that traverses through Delaware County. The figure that's shown in the slide shows the route for the Mariner East 2 pipeline as it traverses to and through Delaware County to its termination point. The existing Adelphia pipeline is an 84-mile pipeline that runs through 5 Pennsylvania counties, including Delaware County, and was originally constructed to transport oil from Marcus Hook to Martins Creek, Pennsylvania. In the late 90s, the northern 34 miles of the Adelphia pipeline was converted to transport natural gas. The remaining 50 miles of the existing Adelphia pipeline system is being converted to transport natural gas of which approximately 12 miles traverses through Delaware County. The figure shown in the slide shows the route of the Adelphia pipeline through the various counties in eastern Pennsylvania, including Delaware County. As previously stated, the quantitative risk assessment used the publicly available information to estimate the individual fatality risk levels from each of the two pipeline systems. As is typically done for pipeline risk assessments, the resulting individual risk levels are then presented graphically as risk transects to provide a way of viewing, understanding, and analyzing these risk results. The individual risk level reflects a hypothetical person continuously present at some distance from the pipeline. This is consistent with common quantitative risk assessment methodology and reflects a hypothetical most exposed individual. Since consequences are generally different for people indoor versus outdoors, separate plots were produced reflecting persons present indoors and outdoors in the original work. However, as the outdoor individual risk is greater than the indoor individual risk, we are just going to focus on the outdoor results here, and when we do the comparisons to common risk sources as we show later. So let's take a look at some of the results that we achieved. The figure that is shown is the outdoor risk transect for the Mariner East 2 pipeline system. The x-axis represents a distance in meters from either side of the pipeline, with the center point representing a hypothetical most exposed individual standing right on top of the pipeline. The x-axis provides the estimated individual fatality risk per year, increasing in risk as you go up the scale. So as you go up on the y-axis, that is increasing risk, and it makes sense as you take a look at the graph that the highest risk to an individual that is standing on the pipeline, 365 days a year, 24 hours a day, will be the most greatest at a point right on top of the pipeline. And then that this risk decreases as you get further away on either side of the pipeline. I would also like to make sure that you note the scale of the y-axis on this transect versus the one that I show next. You'll see that the midway point is about 5 times 10 to the minus 6 for the risk fatality. This figure is the outdoor risk transit for the Adelphia pipeline. The x-axis and the y-axis represent the same items as the previous transect that was shown. A distance in meters from either side of a pipeline, and the individual fatality risk on the y-axis. As I mentioned, you will see here that the scale of the y-axis for the Adelphia pipeline transect is 1/2 of what it was for the Mariner East 2 pipeline transect. This was done for visual purposes so that we could show a broader graph in our examples, but we will utilize the same scale later when we do the comparisons to common risk sources, as you will see in a few minutes. So let's talk about these common risk sources. In typical quantitative risk assessments, the individual fatality risks are measured against tolerability criteria. Those are usually provided by a regulatory body, the client that's commissioning the assessment, or both in some cases. However, due to the lack of any U.S., state, or local regulatory criteria with regards to fatality risk, a comparative evaluation to common risk sources was presented for the 2018 pipeline quantitative risk assessment that was performed. This is something that we decided early on in conjunction with the client so that we could best represent what the risks were from the pipelines and provide an understanding to the public stakeholders what this might mean in their everyday lives. Here on the slide is the list of the common risk sources that we used. Note that these common risk sources are shown in the order of decreasing fatality risk level, or the highest risk with the motor vehicle accident to the lowest risk. being killed by being struck by lightning. For each common risk source that's listed, the corresponding individual risk levels were derived from the Insurance Information Institute's U.S. fatality statistics. Specifically, the 1-year odds of dying as a result of each of these select causes was used. The risk practitioners that completed the work then used the total population of the United States divided by the number of deaths in 1 year that occurred in the United States in relation to each one of these select causes. The individual risk level then that was used equates to the inverse of the 1-year odds. These risk levels were then plotted on the previously shown risk transits to be able to provide a direct comparison of the risks. So let's take a look at that result. Here again is the Mariner East 2 pipeline risk transit. And in the basic graph, you can see the same transit that was shown that illustrates the risk, some distance from the pipeline, of the fatality for an individual most exposed some distance from the pipeline. And what we have done is we've directly plotted each of those common risk sources on this transect so that a direct comparison can be made. Note that the plot contains an inset figure using a compressed risk analysis, the y-axis, to accommodate the motor vehicle accident individual risk value, which would otherwise be off the scale of the main plots. So as you can see in this inset, we have the motor vehicle incident level up here at 1.2 times 10 to the minus 4, and compared to what is now the Mariner East 2 risk level, which is shown here at the bottom of the graph. We then go back to the main plots and we can see the risk of fatality by exposure to smoke in a house fire, the risk of fatality from falls from stairs or steps in your home. And then we go to much lower risk as compared to some of the extreme risk of the Mariner East 2 pipeline, and that is death by drowning in a swimming pool and death by lightning from a lightning strike. And as you can see, based upon where you might be with relation to the pipeline, your fatality risk level compares reasonably well and is less than many other common risks that we are exposed to in daily life. Well, let's take a look at the Adelphia pipeline system as well. Similarly, this figure shows the direct comparisons of on the outdoor risk transit for the Adelphia pipeline, with the y-axis now scaled to match the Mariner East 2 pipeline risk transit. And also, as before, the plot contains an inset figure using a compressed risk value to accommodate the motor vehicle accident individual risk, which would otherwise, again, be off the scale of the main plots. And just like before, as we showed in the previous risk transit, here's the motor vehicle accident risk, and then you still see the risk from the Adelphia pipeline system plotted, now on the much different scale on the y-axis. And again, compared to the other common risk sources, exposure to smoke in a house fire, fall from the stairs, and we go down decreasing to fatality from a swimming pool drowning accident, and then finally being struck by lightning and being killed. As demonstrated in the comparisons made on the previous two transects, it can be stated that the individual risk level estimated for the Mariner East 2 pipeline and for the Adelphia pipeline falls within the range of other common risk sources. Normally, at this point in typical quantitative risk assessments, additional information is then provided from the risk consultants to the owner and/or the design team to assist in efforts to reduce the risk. This is done with identification of risk drivers, or those elements that have the greatest impact on the risk, and possible recommendations to change the design or the operation so that the risk may possibly be lowered. However, in this situation, as previously discussed, this was an independent study, so direct feedback to the owners was not in the scope of our work. What occurred was in the original scope, and it provided the events and experience that enabled us to develop this case study and this presentation. In late November of 2018, the final pipeline risk assessment was made available to the public by the Delaware County Council via a post on the county's internet website. I have copied the link that's provided on for the report. It is still available, and when you get this presentation afterwards, you can go and look at this report for yourselves if you'd like to. Then in mid-December 2018, the results of the risk assessment were presented to the public at the Delaware County Council public meeting room in Medea, Pennsylvania. In attendance at the meeting were members of the Delaware County Council, that's the government body that authorized the risk assessment, employees of the Delaware County, including representatives from our primary contacts, the Emergency Services Department, the representatives from G2 Integrated Solutions who completed the risk assessment and authored the resulting report, members of the press, and interested members of the public. After a presentation by G2 Integrated Solutions that described the objective, scope, method, and results of the risk assessment, the public was invited to ask questions about the report and the presentation. Let me be clear, it's very unusual to hear directly from the public stakeholders when doing this type of assessment. Based upon the interactions at that public meeting, the following items were noted by Delaware County representatives and the lead consultant from G2 Integrated Solutions. There was a high level of understanding of the technical aspects of the pipeline operation and of the methodology employed for the quantitative risk assessment. Questions that were provided at the meeting were very well developed and indicated a significant amount of pre-work that was done by the public prior to the presentation being given. Now, to be fair, I think it should be noted that there might be some specific reasons that could account for some of this. These were highly publicized pipeline projects for that area of the country. There was lots of media coverage, and non-governmental organizations were involved, particularly anti-project groups that had been using or had the assistance from various technical risk and safety professionals and consultants. So while the public provided the questions and the concerns, it might be that there's an underlying reason why they were so well versed in these various aspects. However, that was the situation that we had. A significant number of the questions related to the exclusions of the risk assessments, such as not using societal risk measures. And while the public generally accepted the reasons for some of the exclusions, there was certainly a desire to understand the impacts on the risk of some of the things that were excluded. For example, above ground meter and valve stations were not included in the risk assessment, and there were questions about how the risk would change if these had been. These were not part of the original scope of work that we provided in the report to Delaware County, and that's mostly because that information is not available. The location, the details of those above ground stations is not something that we had the information for. Overall, it was expressed by many members of the public that additional analysis was wanted. Whether this was due to a general dissatisfaction with the results that we provided, and then hoping that maybe more analysis would provide a different answer, or was it a real desire to gain information so they could better understand the risks, we can really only speculate. In addition, in the months since the completion of the report in the public meeting, the Delaware County Department of Emergency Services has observed and noted many items that they have been dealing with. These items include that the public is very focused on what the societal risks of the community are, as opposed to the individual risk assessments that were completed by G2 Integrated Solutions at the request of the Delaware County Council. There are also other major public concerns. They do not believe that proper consideration was given to the impact that introducing highly flammable products, specifically natural gas liquids, will have on the densely populated communities that are along the right-of-way. Public concerns have also been raised about the decision process for right-of-way selection for the pipelines and the perceived need for a public warning system if there is a pipeline release. There also remains an inordinate amount of concern over contamination of the groundwater by the horizontal directional drilling process that was employed and inadvertent returns and other releases of drilling mud. Apparently, there are a number of landholders in Delaware County that are at odds with the operator over well contamination and other items that are attributed to the installation of the pipeline. Let's take a brief moment to discuss the public concerns regarding societal risk. This is something that came up during the public presentation and has been a frequent topic that comes up to the Delaware County folks since the presentation. Societal risk calculations can be very difficult to understand and to properly use. And this is true even for the risk professionals and the global regulators who frequently deal with this concept in their normal work. So let's note several general points. Societal risk measures are used by some entities for decision-making purposes. It is a valid method that is used globally by both operators and regulatory bodies to evaluate the designs and the operations of pipeline systems and other major hazard assets. Societal risk calculations are more sensitive to assumptions and rule sets that are used, particularly in comparison to the individual fatality risks that we calculated in this report. It should also be noted that there is great variation in societal risk criteria that have been adopted by some entities. This is because to use societal risk criteria correctly, you do have to adopt some notion of what level of risks are tolerable. So that finally leads into the concept of voluntary versus involuntary or imposed risk, which may have been an underlying theme in the public's expressed discomfort on the pipeline safety and the desire for societal risk calculations. Voluntary risks are those that you choose to do, like drive your car, instead of walking or taking public transportation. Or you make the choice to buy a two-story house instead of a ranch style that has no stairs. Or you choose to have a swimming pool or not. Involuntary risks are those that are imposed on us, and specifically, that would be like having a pipeline that transports highly flammable materials installed near your home, office, or children's school. Based on these noted items, it is clear that the adoption of appropriate societal risk acceptance criteria for pipeline risk assessment requires careful consideration of many issues that may be unique to each organization or situation. I think it might be interesting to note for this group that a few years back, the U.S. Department of Transportation Pipeline and Hazardous Materials Safety Administration, or PHMSA, was engaged in research to improve the risk management processes that were used by pipeline operators. Part of this research involved an overview of risk tolerance practices that are used by various other industries and in many parts of the world. It should be noted, and it said in this work, that it was not to propose or recommend specific criteria, but to show how others have approached the same challenge. And it was clear that the adoption of common risk criteria and incorporating societal risk into pipeline risk assessments was not to be required by PHMSA. and even more recently, during public workshops earlier this year, where pipeline safety management systems and the application of the American Petroleum Institute's recommended practice 1173 were discussed, PHMSA stated that the pipeline industry is ultimately responsible for understanding and managing pipeline safety risks. And while PHMSA does not intend to incorporate safety management systems into regulation and the rigorous management system that is included therein, other stakeholders may require it. Now, based upon the observations I provided in the previous slides, I believe that the following considerations are reasonable. Pipeline operators could consider conducting public relations initiatives that include risk assessment before announcing and installing systems like the subject pipelines in the risk assessment work that was completed. This would include a demonstration of the input of risk assessments into the routing and final design. The U.S. pipeline industry could also adopt risk assessment practices similar to those used by other industries and countries. This could include the adoption of criteria with regards to fatality risk, as well as the adoption of technologies that provide greater consideration of factors external to the pipeline operation, such as during design and installation, to enable more comprehensive risk assessments and positively influence stakeholder understanding. In addition, the Delaware County Emergency Services Department believes that the experience from these subject pipelines will lead to additional local government scrutiny and possibly additional requirements for the pipeline industry. These may include future proposals for pipelines with high consequence events will likely include requests for societal risk assessments. Installations employing horizontal directional drilling may be asked to conduct frequent and regular groundwater quality tests to prevent conflicts with the landowners. And there is already a push for design standard changes that will impact construction methods and practices, particularly in areas of cathodic protection and in control of drilling mud and inadvertent returns. Furthermore, from the Delaware County Emergency Services, it should be expected that local governments will focus on control of the siting and the pipeline right-of-way and limiting what products can be transported through them. Pipeline operators may be asked to consider providing additional monitoring and flow control systems along the consequence right-of-ways. Pipeline operators may also be asked to consider notification systems to alert landowners of events along the right-of-way to alleviate concerns of timely warning should a pipeline release occur. And finally, continual improvement is definitely needed in the area of open communication between pipeline operators and local, county, state, and federal agencies to minimize disinformation and message creep. That is the primary presentation of what we're going to talk about today. But what I'd like to do in the next few slides is take an opportunity to summarize what we have reviewed. First, I hope that you were able to obtain a basic understanding of the quantitative risk assessment that was completed on the Mariner East 2 and Adelphia pipeline systems. Like I mentioned, this risk assessment was not unusual. The source of data using publicly available information certainly was unusual, and more importantly, the public presentation that was provided and direct feedback received was unusual. Again, it should be stated that the individual risk level that was calculated for these pipelines falls within the range of other common risk sources. But that's not the end of the story. We wanted to make sure that we provided this unique opportunity to the greater pipeline industry. because of the opportunity to discuss this assessment with public stakeholders and to receive feedback directly and through our client, the Delaware County Government Services, we wanted to make sure that we shared this. And as I mentioned, discussing these risk assessments with public stakeholders is not something that's normally done. And it allowed for this development of this case study that we've been able to present today. So the general observations from this experience, many important items. The public desired additional information that was not covered by the risk assessment. Again, whether or not that was because they weren't happy with the results or they were being fed by the frenzy of the media and other reporting about the pipeline systems, we can only speculate. But again, that balance is what we were forced to deal with and what the local Delaware County government is still being faced to deal with. It was obvious that the various stakeholders did not have buy-in for the pipeline projects. Not to say that all of them did not, but there were definitely a vocal group that did not have buy-in. They voiced a concern for the type of products that were being transported and how the rights of way were selected. There was a strong perception that somehow the public needed to be warned in case there was a pipeline release. And the county government is still dealing with some of the construction and installation issues that were done during the construction phase of the pipeline systems. We also talked about societal risk analysis. While it is very difficult to understand and use, it was requested, and it may have impact societal risk analysis on future projects. We also covered the concepts of voluntary versus involuntary risk and talked specifically about some imposed risks that have indirect benefits. Now, what do I mean by this? Well, this is a concept that not just the pipeline industry, but all major hazard industries need to deal with and balance out. For instance, the public may feel that a risk has been imposed on them by a nearby petrochemical plant or chemical facility that handles a dangerous chemical. However, there are many indirect benefits that sometimes are not easily understood by the public. For instance, that chemical that's being used and produced could be the precursor for the cure or the vaccine for the novel coronavirus. Excuse me. Also, more specifically, the natural gas liquid that is being transported to Marcus Hook for distribution and use in the petrochemical and the plastics industry provides many benefits that may not be seen, such as being the start of the supply chain for the plastics that are used in the vehicles that people are driving at a much higher risk based upon their own decision. These petrochemicals are also used in the tires that allow the cars to operate at the high speeds and the conditions that they do. So while a voluntary risk may be more tolerable, there's a lot of balance and communication that needs to be conducted around these imposed risks so that indirect benefits can be understood and explained. And with that, the federal regulator has made it clear that the industry is responsible for maintaining this right to operate these facilities that are hazardous. And finally, we trust that there are many learnings that can be taken from this experience. We've talked about the benefits that proactive risk assessment can have in the design and in the right-of-way selection. We've also made it clear that communications with all stakeholders is critical. However, based upon these experiences, local governments may scrutinize projects and ask regulators for assistance in the areas of limiting the type of products that can be transported and the right-of-way that is chosen. They might seek regulatory criteria for the use of societal risk assessments. And they might request changes in standards for design, installation, and the operations of these pipeline systems. And finally, something that I didn't point out on one of my earlier slides, and that was on the public workshops from PHMSA. It was stated in that second slide that federal regulators are only one bad accident away from mandating additional requirements. What we hope is that the pipeline industry can learn from these and many other examples, take those learnings and apply them to the design and the operation of their systems, of their pipeline assets, so that they can continue to provide all the benefits that we enjoy from this industry. That is the conclusion of my presentation, and as Marissa said, we will be happy to take some questions. While she is setting that up, I also would like to show contact information for both myself and Larry Bach. Larry was our primary point of contact in emergency management for the County of Delaware. He was instrumental in providing information and ongoing feedback that he was getting from various stakeholders. And I want to thank him for being able to be part of this presentation and its development. Unfortunately, Larry wasn't able to join us today. As you can imagine, he's got his hands full with the situation that is facing all local governments right now. So I'll turn this back over to Marissa to facilitate.
Sure, thank you, John. We do have time for some Q&A, so let's see what questions came up. Do you believe that the risk levels would have changed either higher or lower had you included additional items such as above ground stations in the risk assessment?
Okay, so yeah, that's a great question. And those are the type of sensitivities that quantitative risk assessments do all the time in their normal use and practice. Unfortunately, I can't really answer the question as to which way the risk would change. Because we had only publicly available information, like I mentioned, the above ground stations, metering stations, valve stations, et cetera, were not, those details weren't available to us. If they had been, we would have done detailed review, do what's called a parts count, which is a detailed review of each element, and have statistics about the failure potential of each one of those elements within that above ground station. And that would all play into the calculation of the risk. However, that being said, if we had that level of detail, it might be that some of our other conservative assumptions that we made may have been turned down a little bit and made less conservative. So there may have been some buy-off between more information being less conservative. And so again, I can't really answer that question specifically, but it is a great question with regards to available information and how it's used in an analysis like this.
Okay, based upon this experience, do you feel as though the pipeline industry is doing a good or a bad job with respect to pipeline safety and public perception?
Yeah, okay. All right, well, that's a loaded question. It is not our position today to make a judgment on the pipeline industry. What I was intending and what Larry is intending is he wants to be able to present the information that we have found during this experience so that the pipeline industry can make use of this and decide that it is something that's important for them. What we are very concerned with is that we need to make sure there's a balance, that everyone in the industry is able to work within and to have that balance achieved with local, state, federal regulators, interested agencies, and of course the public and the media. And that balance is very difficult, and that's a independent, not just a another topic for a webinar, but that can be a full long study and lifelong employment to work on that balancing act between all those entities.
All right. This one says, to follow along with your answer, should it be mandated to provide that level of information so that a more detailed analysis can be done?
You know, if the industry, and that is the operators themselves, decide to take on additional risk assessment work like we detailed here today, they will have that information available. Do I think that that information should be provided in a public domain so that all different types of folks can take on quantitative risk assessments? You know, to be honest, I'm not sure that that would be the right answer, because the amount of assumptions and the way that you work through quantitative risk assessments can vary. And just like any other type of scientific work, there can be questions as to how robust and how technically correct something can be. You know, my personal feeling is that these types of studies really are best done and most accurately done within the operators and the design teams. They have that information, and then they can choose based upon what they feel is necessary as far as in releasing that information to the public, what provides them with the best basis for achieving that right to operate, and to say, yes, we are doing what's necessary to provide the best and safest operation that we can in the places where we operate.
Okay. This says, were the stresses of the public concern about their personal safety included in the health risk assessment?
Could you repeat that, please?
It says, were the stresses of the public concern about their personal safety included in the health risk assessment?
Oh, okay. So whether or not the stress itself was something that was calculated, you know, on a fatality risk assessment, you have to choose what kind of harm you can adequately review, analyze, and calculate a risk of dying. And the stress of these systems being installed and operated, yeah, it might have, you know, wreak a certain level of health issues on people. That, I mean, that is you know, definitely true. That can happen with, you know, almost anything. I mean, the health issues that all of us are having right now, I'm talking mental health and stress, under our current situation, obviously is going to have some toll. But how that is then utilized and calculated into a fatality risk, I'm not certain that that is either going to be material, nor is it going to be that well known.
Okay, this one says, where did you get the public data set from?
The public data set. Well, there's different pieces of information. If you use the link to the report, you will get a full detail of all the various references that were used. We used US DOT PHMSA statistical data on the release frequencies. The harmful consequences were modeled using typical tools that are used in the quantitative risk assessment industry. Whereas we modeled those releases and then measured the amount of harmful effects at certain distances from the pipeline. And as I detailed or mentioned in the slides, those were thermal radiation from jet fire and from oh, I apologize. Two different for the natural gas liquid from radiation, and then the overpressure from the vapor cloud explosion for the natural gas on the Adelphia pipeline. But those are typical methodologies that are used in quantitative risk assessments, and the basis for which we developed the method, again, was utilizing standard types of documentation and work that's been around for decades. in this type of analysis.
Any big issues in dealing with FERC?
Dealing with FERC.
Yeah.
We did not have any direct interaction with FERC. So in this situation, no, we did not, and it was not part of our scope, nor was it anything that we ran across in the work itself or in the presentation.
Okay. Why did you not evaluate the jet fire consequence scenario for the natural gas pipeline?
That will be detailed in the report, and I will give you my best summary is that it either has to do with the type of release and the consequence of the jet fire. I believe that, and again, I'm speaking that may be something that is contradictory in the report, so I will go back to that if if I'm wrong. But I believe it has to do that the jet fire from the natural gas hole size would not provide the same type of consequence that would be fatal if some type of ignition source was available. And I apologize, I'm stumbling all over that question. That's because that goes into some of the detail of the QRA, which again is detailed in the report that is available on the public domain.
Okay. Is Delaware County having G2 go further since the public meeting with additional assessments?
No. At this time, there has been no decision to go any further. And of course, we would welcome, and we still are in contact with them, obviously, for the development of this work. But no work as far as commissioning additional studies as such.
In your opinion, is societal risk a good tool to avoid ruptures like San Bruno with high fatalities?
Well, is it a good tool? I think going back to the discussion that I had on several slides on societal risk, it can be a good tool, but it has to be carefully used and applied. And societal risk, if you calculate it, essentially does not mean a whole lot unless you have a tolerability criteria that has been determined with the use of that societal risk calculation. So again, you can come up with a number like we did on the individual risk fatality numbers, but then you have to be able to do something with that. If not, it's just a number. You could utilize societal risk tolerances that are used by different entities that are available, public information. You can go to Australia, where societal risk calculations are used in the approval and acceptance of designs for various major hazard assets. Also the same thing for the UK with their HSE. They also have societal risk tolerability criteria. So is it helpful? Yes. Does it have to be done carefully and with a lot of work? Yes, absolutely. Will it prevent events like San Bruno? That's the one thing about major accident events. They are infrequent, but they do happen, and there is no such thing as zero risk. So what we do as risk practitioners and professionals, and what we can assist with the industry, is provide this type of analysis so that we can understand what is driving the highest risk that's involved with these assets, and work within the industry to help decrease the risk that we are exposing to the workers and to the public, and to remain with the right to provide and use these assets.
Okay, lots of questions. Was it an 8-inch pipeline system, and were there any issues with the valves along the system?
Could you repeat that first part? I'm sorry.
Was this an 8-inch pipeline system?
Let's see. Well, we had the Mariner East 2 was a 20-inch pipeline, and the Adelphia, if I remember correctly, from was an 18-inch pipeline. So the question was about an 8-inch.
It just asked if it was an 8-inch pipeline system, and then it says any issues with valves along the system.
Well, again, we had to assume that everything was just buried pipeline, or so buried pipe that was at a minimal and nominal requirements as usually done in the industry. And again, that's based upon not having the detailed information for these specific systems, whether or not there were valves, isolation valves, above ground valve stations, et cetera. We just didn't have that information to be able to utilize in our work.
Okay, and this one says, will the slides be available? And I can answer this one. Yeah, after this today or tomorrow, I'll send everybody out a copy of the presentation as well as a link to listen to the recording. So go ahead and be on the lookout for that, as well as information on our future webinars. But let's cut it off right there. We do have several more questions. And so I think maybe we can write up a document with all of these questions and John's answers and send them out to everybody, or John can reach out to everybody individually, because that's all the time we have for today. But we hope you have a great rest of your day, and we will see you back next week. Thanks for joining.